Alright, we're back with the next portion of our question and answer period in this week's tutorial. And we're going to go to number 5, determine the values of a, b, and c for a function defined by f of x equals ax minus 2 all over bx plus c with a vertical asymptote of x equals 4, a horizontal asymptote of y equals negative 3, and an x-intercept of 1/3. Alright, let's take a look at this equation. Well, we've got the top here, ax minus 2. When that equals 0, we know that we're going to have a 0. We know that the whole thing is going to equal 0, as long as the bottom doesn't also equal 0. So at the end, we'll just have to double check that that doesn't happen. Make sure it's not a hole. Alright, so let's try that out. When we know that we need that to happen at 1/3. So when x is equal to 1/3, we want ax minus 2 to equal 0. So at x equals 1/3, we know that we want ax minus 2 to equal 0, because when x is 1/3, we want this whole thing, we want f of x to equal 0. Another way of saying that is f of 1/3 has to equal 0 for it to be a 0. Okay, so we know that the top has to be the part that equals 0. So ax, oops, let's go, instead of ax, x has to be 1/3, so we're going to say 1/3 times a times 1/3, or 1/3 times a, minus 2 has to equal 0. Let's call that equation number 1. From equation number 1, actually, I'm going to back that up. We don't really need to do that yet. We could straight up here. We can say that 1/3 a equals 2, which means that a is equal to 6. There we go. A equals 6. That'll help us. Alright, now the next thing I'm looking at is the bottom. When the bottom is 0, well, that's when we're going to have ourselves a vertical asymptote. Again, as long as the top and bottom aren't both 0. So we're going to have to be mindful of that, and we're going to have to check that out at the end. Alright, so we can say at when x is equal to, where's our vertical asymptote? Vertical asymptote has to happen at x equals 4. So f of 4, can't equal 0, has to equal 1 over 0, but that's undefined, so that's not exactly something I want to put. I'm going to say at x equals 4, bx plus c has to equal 0. Okay, so let's let x equal 4, so that means b times 4 plus c has to equal 0. Okay, we're going to save that as equation number 1. I never named my other equation, so I could just call this equation number 1. And what else do we have here? We have a horizontal asymptote. Well, the horizontal asymptote, since the degree on the top is 1, and the degree on the bottom is 1, they're both degree 1, so we know that the horizontal asymptote will happen at a divided by b. If we actually went out and divided ax minus 2 by bx plus c, your answer would be your horizontal asymptote of a over b. So a divided by b has to equal, the horizontal asymptote is y equals, has to equal negative 3. Alright, well, we already know a. So maybe this should have been called equation number 2, and this should be called equation number 1. That way I can say from 1, 6 over b equals negative 3, which means that that b is equal to 6 over negative 3, which equals negative 2. That's b. Okay, so there is, we'll call that 3. And then we've got this 4b plus c equals 0 over here. Well, I know what b is now. So 4 times b, which is negative 2, plus c equals 0. And this is starting to get a little bit messy. Let me try to section these guys off. And this one right here is from 3. From equation number 3, we we got that b is equal to negative 2. And so that we know that c is equal to 8. There we go. So a is 6, b is negative 2, and c is 8. Let's put that in. A is 6, so we're going to say f of x equals 6x minus 2 over b is negative 2, negative 2x, and c is 8 plus 8. Alright, now I have to double check and make sure that I'm right, because I need to know that there's not a hole there instead of a 0 and an asymptote. So let's get this into factored form. It's probably easiest. We're going to say 2 times 3x minus 1. So it looks like we have a 3x minus 1 on top, which tells me that at 1/3 we have a 0. Is that what we wanted? We have a 0 x-intercept of 1/3, yeah. And on the bottom, we are going to get negative 2 times x minus 4. And that would mean we have an asymptote at x equals 4, and it doesn't cross out. It's not a hole. Let's see, x equals 4. Yep, that's when we wanted our vertical asymptote. This 2 and negative 2, I want to cross those guys out. I'm going to say f of x is equal to negative 3x minus 1 over x. I divided both sides by negative 2. There we go. So here is our equation, but the a, b, and c values are really what we were looking for earlier. And there it is. Let's go to the next question. Number 6. Constants a and b that guarantee that the graph of the function defined by f. Find constants a and b that guarantee that the graph of the function defined by this will have a vertical asymptote of x equals 2/3 and x equals negative 2/3, so vertical asymptotes, and horizontal asymptote at y equals negative 2. Alright, let's start with the, well, first of all, let's rewrite this equation so that the leading coefficients are more obvious. We got ax squared plus 6 over negative bx squared plus 16. We don't want the x squared to be at the end. We want it to be in front. Okay, so, and we already know this is x squared, degree 2, degree 2. So the horizontal asymptote will simply be, since they're the same degree, a over negative b, whatever the leading coefficients are, right? So the horizontal asymptote at y equals, I'm going to call it negative a over b. I like the negative to be on top. And what does it say? We have a horizontal asymptote of y equals negative 2, so that equals negative 2. So negative a over b equals negative 2. I'm going to call that equation 1 in case I need it in the future. Alright, what else do we need? We need a vertical asymptote at 2/3 and at negative 2/3. That means at 2/3 we're going to have, so when we have negative b times 2/3 squared plus 16, so that's the bottom here. That's this bottom here, but with 2/3 as x. And when x is 2/3, we need this to equal 0. So we want the bottom to equal 0 at 2/3. That means you're going to have a vertical asymptote there. Of course, as long as the top doesn't also equal 0 at 2/3. We'll just have to make sure that that's not the case. Alright, looks like we could solve for b here, no problem. We're going to have negative b times 2/3 squared equals negative 16. Those negatives could go away. We're going to get b is equal to 16 times 9 divided by 4. Because 3 squared is 9 and 2 squared is 4. And so this is b is equal to, that's just going to be 36. 4 times 9 is 36. Boom. Alright, so we know b. But also, negative 2/3 is going to have, well, that's going to be the exact same thing. b times negative 2/3 squared plus 16 equals 0. Well, of course, it's when you square negative 2/3, you're going to get negative b times 4/9 as well. So you're going to get the same answer. All right, so b is definitely 36, and from, we're going to call that number 2. So from 1 and 2, we're going to have negative a over b, which is 36, is equal to negative 2. Okay, so negative a is equal to negative 72. Well, that means that a equals 72. Alright, let's just test out that thing. You guys know that checking your answers is the most important thing in my book. So you have ax squared plus, oh no, I guess the equation's right there. You got ax squared plus 6. So really, therefore, f of x actually equals a, which is 72x squared plus 6 over negative b x squared. Well, b is 36, so this is negative 36x squared plus 16. And let's just double check. Okay, so we know that a horizontal asymptote will be negative 2. Is that what we were looking for? Yep, y equals negative 2. Perfect. And the 0 on top. Did we talk about the 0 on top? No, we don't. Oh, that's good news, because there will be no 0 on top. There's no x squared that'll make that 0. And on the bottom, we've got our zeros of negative and positive 2/3. That works. Awesome. Okay, I'm going to end this video and continue in a few more minutes. You'll get another video coming up soon.